Hello, hello. Welcome, everyone. Thanks for joining today. Wherever you are, good morning, good afternoon, good evening. My name is Madhu Kumar Aluri. I'm a AWS Hero and UG leader based in Budapest. So we have the AWS Container and Artificial Intelligence AI ML group. So this will be the first event, and warm welcome to everyone. So we have two guest speakers from Amazon Web Services who are container experts, and I would like to introduce to them. And yeah, without any further ado, I would like to call Darko on the stage. And yeah, Darko,
Thank you so much, Madhu. Did you just call me a container expert? Oh my God,
you are AWS
that
guru, not
that's
just
that's
containers. Yeah.
that is saying a lot. Oh my God. Okay, good. Well, thank you so much for letting me be part of this. I appreciate it. Hi, folks. My name is Darko. I am, as Madhu says, an AWS guru, I guess. No, I am what they call a developer advocate these days, and I get to talk to you about technology, cloud, open source, containers, serverless, generative AI, and everything in between. And today I'm going to be doing a couple things related to containers, so I hope you're having fun. I'm originally from Serbia, so I actually, if you can see my name, it's Darko Mesaros, so I am kind of a bit of a Hungarian myself. So I'm currently living in Seattle, Washington, and it is a very early morning right now. It is 7 a.m. I am just got up, got my first cup of tea, and excuse my voice, but I'm a bit sick today. So I'm gonna try my best to be as entertaining as possible while not looking too sick. Uh, okay, Madhu,
Cool.
I guess I'm gonna take it from here. I guess.
Yeah, and do you want to just quickly introduce maybe
No,
Adam as
no,
well, just
no,
real
no,
quick?
not, don't, no, don't add Adam.
No?
Just
No?
kidding, just kidding, just kidding.
I have another.
No,
Yeah,
no, it's my
Adam,
show.
just
It's
say
me.
hi, and maybe probably we can just say it. Thanks,
Oh
Jeff.
man, that's awesome. Thank you. First of all, it's always hard. I'm going to go after Darko. It's always hard to follow up after Darko because he's just he's top tier. So the good news is he's sick, so maybe he won't be as good today. So it can make me look better. I'm just kidding. Anyway, really happy to be here. So my name is Adam Keller. I'm a senior developer advocate here at AWS. I like to call myself a senior technologist because we talk a lot about AWS technologies, and my area of focus is really anything around modernization, modern technologies. I'm a big fan of containers, serverless, um, and my big area of focus these days has been around infrastructure as code and DevOps and automation. I was kind of born in and Darko, you'll see all the Darko's cool stuff with all the old technologies he brings out. And I was around in the days when I needed to get an answer to a question, I had to find a book and look through my Linux Bible to find the command that I needed. And anyway, so really good to be here, and I look forward to chatting with everyone.
And
Cool.
Madhu is here,
Thanks,
and that's great.
thanks. I'm just messing with this thing. Okay, I think I'm just checking how many are at the moment streaming. That's good. Okay, so I think Darko, stage is yours.
Thank you so much. Thank you so much, Madhu. What can I say? And also, Adam, don't sell yourself short. I'm just a pretty face here. You're gonna be the one who's gonna be teaching people actual stuff. So Adam is the expert when it comes to kind of application modernizations, containers, and everything. I had really great discussions with him in the past on live streams and in person. So if you're looking to learn about modern application development best practices, containers, and also everything in between, Adam is the person to talk to. Okay, so folks in the chat, if there are people in the chat, please do say hello. I am going to be sharing a bunch of links as we go along in the YouTube chats. So I have YouTube kind of open here, so you may see it here on my screen. Here, look at that. So what I'm going to be talking to you about today is this. Yes, that. Yes, this. So this thing you're seeing right now, that is an ECS cluster. That's a container cluster. And I'll talk about how and what in a minute. So So let me go back and talk to you about, well, I'm going to talk about ECS Anywhere. So basically what I want to talk to you about is how you can run containers anywhere, but still manage them with the control plane of Amazon Elastic Container Service, right? So if you've been running containers on AWS, most likely you've been doing it through ECS. And I'm going to show you today how you can run ECS, well, anywhere. So without further ado, Manu, can you share my screen right now? So I should have, boom, look at that, yeah. I want to show you first thing here. So if I go to a link and I do mechcluster.rup12.net, yes, this website right now, which I'm sharing in the chat right now, if you go there, you are actually going to be invoking an application in, well, in that little thing here. So this thing is running a simple web application on a few, well, 3 Intel MacBook Pros. These are all 2007 MacBook Pros running Intel Core 2 Duo CPUs. And if you see, I refresh, you will see it flips back between a few of them. Like this one has 4 gigs of RAM, this one only has 1 gig of RAM, and there's one with 2 gigs. So if I look at that, that's 2 gigabytes of RAM, yeah. So that is happening right now. Now, should you do this on old MacBooks? You should not do this on old MacBooks. By no means, right? This is just for me to demonstrate to you how you can do that. And I'll show you how I exactly did this whole thing behind me in a moment. But before I go to that, I need to go ahead and talk about my inspiration for this. My inspiration is the most amazing, the most excellent, almost as good as Adam, Nathan Peck. Nathan basically wrote a blog post a while ago how he used ECS Anywhere, not with MacBook Pros, but he used it with his little Raspberry Pi cluster. There you go. So he has a little Raspberry Pi cluster, and basically he did the same thing. I think it's currently down, the website doesn't work, but basically he said the same thing. Oh, hey, look at that, look at Nathan in the chat. It does look familiar, absolutely. So Nathan is the person to blame for all of my mischievous actions these days and how I built it and why I did it. Basically, yeah, he was the inspiration for all this. So make sure to go ahead and smash that, whatever you call it, bookmark, follow button on this blog post here in the chat. So yeah. Basically, that's a really great way to get started. Second blog post from Nathan I'm also going to be sharing here as well is very much related to this, and that is just that. Okay, so let's actually go ahead and close this off, and I'm going to go and show you how, well, actually, what is ECS Anywhere? I'm going to do this. I'm going to open up documentation. I have no PowerPoint these days. I just look at websites and type code into an editor. So what is ECS Anywhere, right? And it's weird because like when you go to the documentation, this seems like it's all the documentation. There's not a lot, but it is actually quite more powerful, quite more robust than you usually approach things on AWS, right? So if you search for AWS ECS Anywhere, you'll probably get to a landing page like this. And in essence, the way it works is that you want to use the single control plane to run containers anywhere, right? So whether those containers be on AWS, in your data center, behind your face in a small little rack, or, well, actually running some production application in like a very low latency requirement workload, right? So instead of having multiple different control planes, you can use things like ECS Anywhere and use the same wonderful console and the way you deploy things just to do that, right? You can even use infrastructure as code, which Adam is going to be talking about in a moment, to deploy all of the things you need to run your application even locally. So that's the whole point. I'm going to take a step back here for a second and talk about running containers on AWS. I'm gonna assume that most of you know what containers are, right? Why should you run containers? Why is this a thing? Oh God, Maish is in the chat. I'm surrounded by container experts right now. I feel very much watched. So I'm immediately gonna I'm gonna say I'm sorry if I say something wrong, my friends. So Nathan, Adam, Maish, come on. So first of all, running containers on AWS. There's multiple ways. I think there is 17 ways to run containers on AWS. I think people can correct me if I'm wrong, but there are a plethora of ways to run containers on AWS. From running them on your bare bones EC2 instances to using something like ECS, to using EKS, to using Elastic Beanstalk, to whatever, right? Many ways to run containers. Today we're talking specifically about ECS and its ability to run containers anywhere. So running containers on ECS is relatively straightforward. It's you create a cluster. Basically, you provided the compute requirements, what you need to do. You create services which run tasks, which run containers. That is as simple as that, right? You create a service. You say this service will be running 5 instances of this specific task, and that task is basically just a bunch of containers. So yeah, let me actually go ahead, and I think I'm going to show it to you right now in the in the thing here. Look at that. That's the ECS. ECS. Well, what's the word? Dashboard, not dashboard. The console. Yes, this is where you go create a cluster. In that cluster, you create a service or a task. And within that service, you pick a specific task definition to be executed. So I'm not going to go into the details on how things are being run by default. What's your typical setup on like local, like your just normal AWS native, cloud native ECS setup. I'm going to be talking about ECS anywhere. So let's go ahead and let's go ahead and set this up. So I'm gonna manually set this up right now. So what I have right now here is a virtual machine. Look at that. Hyper-V. Has anybody here used Hyper-V in the past? Like, please, is this, am I the only one who's used Hyper-V in the past? If you have used Hyper-V, please do say so in the chat. But yes, I have a Hyper-V instance here running on my local workstation, running Ubuntu server. So let's see, Neo. I know it's too small for you to see. It doesn't really matter. I just want you to know that this is Hyper-V. It's basically virtualization on Windows, and I'm very angry with Windows 11, or actually Windows 10 and beyond. They make it so hard to use any other virtualization software locally if you want to use Windows subsystem for Linux. So it is kind of a pain that you have to use this, but okay. So I want to add this instance, this virtual machine running on my computer right now. I want this thing to be managed. I want the containers running on this instance to be managed by ECS. So let's go ahead and do that. Okay, I'm going to go create a cluster. I'm going to call it, what am I going to call it? I'm going to call it containers from the couch, because I see containers from the couch. So if you have not seen this show, Containers from the Couch is a live stream show right here on YouTube and Twitch. Again, hosted by the most amazing people, a lot of the folks in this chat. You should go definitely check it out. So creating a cluster, specifically, I'm gonna enable external instances using ECS anywhere. So I'm basically gonna say, hey, you can use ECS anywhere instances inside of this cluster. I can uncheck these. These are some different these are some other options of compute. So like Fargate, these are serverless containers, or actual EC2 instances. I'm going to just leave this as using ECS anywhere, and I'm going to say create. So what is this is doing right now is actually creating all of the elements required for a cluster. And actually, weirdly enough, it launches a CloudFormation stack for you. So you'll see there's a whole CloudFormation stack that creates a bunch of different things. In this case, I think it's just an ECS cluster. I don't know if it creates anything else besides a cluster, which is always kind of weird. But the reason it's all kind of bundled like this is that when you create your services and tasks, you can kind of all delete the same thing. You can delete the entire thing at the same time. And again, it's managed by CloudFormation, which which is pretty darn nifty. So it takes a moment for this thing to set up, but you will see here that it's showing up, no tasks running because there's nothing there. So when I go there, you see, create successfully. Let's go ahead and create us. Actually, infrastructure. I have nowhere to run containers on, right? If I go ahead here and just create a container, I have nothing to run it on. I have no container instances, nothing. I have no capacity to run this thing. So even if I go ahead and create a service, there's nothing I can. There's no instances. I won't be able to run anything. So I need to add instances. Imagine that this thing here, this thing right now, is my, it is my server running in my local rack or network or my factory, my low latency requirement environment. And I need to add this thing here to my cluster. Well, it's simple. Infrastructure, register external instances. That's it. So basically, it does, of course, have a significant, well, I'm not sure if it's a significant, but it does have a pricing impact because there is something you have to pay for all of the managed instances, even if you're running locally. So the management aspect of it, there's a cost to it because you're using something called AWS Systems Manager to basically bootstrap and manage external instances into your AWS account. So I'm going to set this just 15 just to be sure. These registrations are basically just kind of a activation key, secret key pair combos, which allow a specific number of instances to be registered to your cluster. Now, I'm going to say 1,000, but it doesn't matter. I don't think I'm going to be registering 1,000. I just need one. And also, you can define a specific instance role. So what's beautiful about this is that this gives the ability for these little things behind me to actually have permissions to AWS natively, right? So they get an instance profile attached to them. So anything that's being run on these servers is being done through what is it called? Like an instance role. So you have specific permissions you can use and set up while doing it. So I'm going to be using specific ECS external instance role. There is one specific one you need for this case, right? There are specific requirements the role requires for you to have. So yeah, it is. I don't know if it's. I would assume it's probably defined somewhere when it comes to this thing. But yeah, there's some specific requirements to the role that you need, basically, so your instance is able to communicate with the ECS cluster. Okay, I'm going to say generate registration command. And that's it. So it creates you a Windows or a Linux command. This means, in essence, I could register my desktop here, my good old Windows desktop, to be, I guess, a container instance in the cloud. But I don't want to do that. So I want to take this, and I want to copy this command, and this command will basically do all of the bootstrapping needed to get your instance running on the cloud. Now, since this is a virtual machine, I need to connect to it using PuTTY, good old PuTTY. And I know we're all in Windows territory here, and I apologize. I don't usually use Windows, but camera software and just having a good old live streaming experience is way better in Windows. So, okay, I'm going to connect to it using PuTTY. Give me a second. I'll increase the font size in a moment so you can see. Let's see. Change settings. Let's make this uncomfortably big. Apply. Awesome. So this is my Ubuntu server. Remember, NeoFetch. It's that. If I run the command right now, so I'm pasting the command. As you can see in this command, and of course, you get to see my activation code and all that fun stuff. So feel free to register your home instances to my cluster as well. Basically, what I'm doing here is installing ECS Anywhere to a specific cluster. It's running the installation script, and it's passing the cluster name, activation ID, and the activation code. Like that. Installation fail. Sudo su. Okay. Because of course you need to run this thing as su root. Once again, nope, that's not it. Let me copy the command again. Boom, boom. Okay, I know what's wrong here. So this is my instance issue. Here's the thing. For some reason, I cannot write to TMP. This script won't run right to TMP. So I'm going to do the following. I'm going to save this file locally, just here, like that. And then I'm going to be doing the stuff like bash ECS anywhere. Look at that. Boom. Okay. As you can see, it's running a bunch of different things. In updating Ubuntu, it does detect what kind of a OS you're running and all those things. It's setting up all the stuff you need. Like it's gonna install Docker for me. This is a brand spanking new instance. Nothing. I did nothing on this thing. So it's setting up all of the stuff I need. And as soon as this is done, it's gonna set up Docker. It's gonna set up SSM. So it's basically gonna register this instance to my AWS account. And it is also gonna set up the ECS agent. So for the ECS agent, there's a bunch of different things you need to do, like configure the configuration file and actually set up the service. So you can see here, it is waiting for the ECS agent to start. By the way, I see Madhu posting the link in the chat. Please do fill in the feedback form if you consider these kinds of sessions useful for you. Let Madhu know what you're thinking about these kinds of things, and should we do them more? Okay, so it is successful. If I do systemctl ECS status ECS, you will see that this active is running and it is connected. And now, hopefully, if I go back to here, close this, look at that. What is this? I'm sorry. Do I have some instances ready? Oh, look at that. Instance ID, MI, that's not your typical instance ID. Well, actually, if you click on this whole thing, you will see here it is a Linux platform. It's a hybrid instance. It is an Ubuntu server with my local IP address. Right? This thing is running locally on my little workstation here. Erhard is asking, what kind of a PuTTY settings do I need? It doesn't matter. PuTTY is just a SSH client in this case. You can connect to your EC2 instance in any way. Sorry, to your container instance in any way, shape, or form. So whatever works for you, it's fine. So in this case, I'm just using your default PuTTY configuration. Okay, so we have this instance available in our cluster, and now technically, you see it has a bunch of has 16,000 CPU. What would you call these things? Like, it doesn't have 16,000 CPUs available. It is 16,000 CPU units available. I think it's 1,000 per core or thousands-ish per core. And if you have a look here, if I do I have HTOP? HTOP. I have 16 cores on this CPU, so that's good. Awesome. So let's go ahead and create something here to actually run something on this thing. So containers from the couch. I'm going to create a service. I'm going to say this is going to be an external service. Perfect. And I'm going to just use an existing application that I have in my, actually, it's an existing application. It's an existing task definition that I have in my account. So, and I'm going to call this, what am I going to call this? Containers from anywhere. Look at that. Even the couch. Even the couch. I'm going to say I just need one desired task, and that's it. Create. So, in a moment, what should happen right now is once this thing is launched, this task should be launched on the following infrastructure, I think. So, it does take a few minutes because if you remember, it's all being done through CloudFormation. Now, if I go back to the CloudFormation stack, you will see that there are some the services being created. It's an actual separate. Interesting. So that's a different approach. I thought the services and everything else is going to be part of this entire stack. Odd. Okay. Well, it is creating all of it as part of a CloudFormation template, which is perfectly fine. So once the service has been created, it's going to be available here. It takes a few minutes. While that is happening, let me emphasize the following. This application is going to be launched locally in my home network. Now, you're not going to be able to access this application by default. By default, this application is running locally, and there's no networking magic done here so you can access this application from anywhere, right? You need to set up additional things to be able to actually serve your application through the internet well, from your local workstation or data center or whatever you like to call it. So in this case, it is going to be just available locally through the local network, nothing else, which is also fine because sometimes that is actually what you want to do. You just want the control plane. You just want all of this to be basically managed through Amazon ECS. So, okay, I do have a task running. I see this. It is running, I think, on, if I go here, there should be a task running. You see one task is running. That's good. If I go to my instance and do Docker PS, look at that. There is something running here. Look at me. There's an agent here. So there are two containers. I hate Docker PS. There's the ECS agent running here. That's okay. And also there's the actual application running here. So if I would go and look at this thing right here, no, not that. Rather, where is it? There you go. Go to my instance and look at my IP address. This is, remember, this is just a local IP address. Go here, paste, and I think it's 3,000. Is it 3,000? Or is it 8,000? Or is it just 80? I maybe just, look at that, yeah, okay. Yeah, so the application is wrong itself, but it is running on a different, see, it's an i9, it's a 4 gig model. Yeah, it is a different system. But I just deployed this application locally onto, well, this little virtual machine. So that's how you do it. Simple as that. Now, I'm going to go ahead and show you how I did this. So for those of you who are just joining us, this thing right now is, so I have this bad obsession of collecting gold computers. These are MacBooks from 2007. These are MacBooks running Core 2 Duo CPUs, and that's it. Just your typical white plastic MacBooks. They have Debian Linux installed on them. They have batteries removed, and they're disgusting. So, like, you can't see it here, but like, they still have stickers on them. I got them for free, basically. I got a box of them for free, and I managed to get them working, and I made a little cluster for them. Even this thing here, this is just a piece of wood that I cut up, so they would nicely fit into this little small rack. So these these laptops are running ECS Anywhere. I'm going to show you how I set this all up. So we go back to my face again and show you how this application, maccluster.rob12.net, is running. So I have it all set up through well, CDK. And, you know, I'm not going to go into depths of what CDK is and how does it work because the most amazing Adam Keller, who's coming up after me, is going to be doing that. But I set up everything here using CDK. So I'll show you first what it is. But here is my cluster that serves, well, 3 services in this case. It has 3, well, servers or capacities, container instances, basically these 3 laptops. And it has a bunch of different tasks running on them, right? So this is all running on those, well, not all of them. Most of these things are running on those laptops. So let me actually show it to you how did I set this up. And I'm going to be showing this to you through CDK. Now, Adam is going to go into depth on this, but CDK is the AWS Cloud Development Kit. It's a way for you to write infrastructure. Instead of me looking at me clicking a bunch of buttons here, creating clusters, you can all write this in a little in your language of choice and have it all automated. So I'm going to show you how I did this. So repos, I think I had, yeah, there we go. Okay. I'm going to show you CDK lib. So, okay, this is my CDK project for this application. I want to preface this by saying it is not perfect. It is far from perfect. it can be way better than it is. I kind of made it work. I still want to do a lot more things, but technically, if you would open this and run it yourself with a couple of little changes, you should be able to do this, right? So, a couple of things that it does here. Number one, it creates a VPC, right? It's your typical AWS Virtual Private Cloud, your networking setup on AWS. It creates an ECS cluster. That's it, right? Instead of me clicking a bunch of buttons, it creates a cluster called, well, it gives it its own name. I am using something called inlets. Now, inlets is a third-party product. I cannot say it's the best thing in the world. I cannot say it's the worst thing in the world. It is a paid product. It basically allows me to set up networking without any fuss. Remember how I told you that you cannot access my application from the virtual machine, right? So like the application running on this virtual machine is not accessible to you. Yeah, it doesn't. But the application running on these boys is. Well, that's because I'm using inlets. Inlets is basically a way to create VPN tunnels between these boys and your AWS. So what I did here is using inlets, created a tunnel between the MacBooks and AWS. Well, and this specific VPC in this case, and this is how I route traffic through a load balancer through inlets to these laptops. It's a paid service. It costs, I think it's a monthly fee depending on who you are, what you do, and all that fun stuff. But it was definitely the simplest way to do it. And again, I was again inspired by how Nathan built it. So here's the blog post from Nathan. I think this is where he mentions inlets. I think I'm not sure if this. No, sorry. This is the inlets post. Yeah, how does this work? So if you want more details of how inlets work and how this is all set up, basically I stole everything from Nathan. So you can find it all here. Absolutely. Okay, so I'm just using this to retrieve a secret basically a registration key for inlets. That's it. You have to pass it your registration key, and I'm keeping it in Secrets Manager so I don't have to hard code that thing in my CDK stack. So yeah, license key, basically pulling that thing out. I actually don't even know why I'm doing this. So look at that. Look how bad my code is. The inlets token. Is this a thing I'm doing? No, this is fine. No, okay. So the inlets token is a specific string I'm generating that's going to be used. It's generated every time it's being done. It's nothing special. This is the license key, yes, because I keep this license key inside of my account. These are exit servers. These are the inlet exit servers, and these are the tasks. If you go back here to my ECS thing here, cluster, you will see that I have a bunch of the tasks here, and some of these tasks are running on Fargate, and these tasks are basically exit servers. These are inlet exit servers. This is what creates connectivity from the laptops to the VPC. So, because what's going to happen is I'm going to have these things. I'm going to have the what inlets running on the laptops communicate with the inlets running on Fargate. So every time a instance spins up, a new server is added, it's going to add a little inlet server to it, and it's going to connect to one of these exit nodes. Mike, hello, welcome to the show. Yeah, there's no Python here, Mike, today, but you're welcome to stay. Hey, it is all the cloud. Yeah, maybe Adam will get you some Python. I don't know. Okay, so that is about that. These are the container setups. These are basically just all the ways you can set up your containers and everything else on the cloud. You will see here. This is how I configure my container myself. This is how I set up the command to run the container from. This is a specific container. See, I'm using the inlets container image here. Hey, Ahmed, welcome to the show. It's not on your channel, Ahmed. This is a meetup organized by the most amazing Madhu. So yeah, this is the AWS Budapest user group, basically. So specifically focused around containers and artificial intelligence. So yes, exactly. It is not my channel. It is. I'm just giving the most amazing opportunity to be part of this. So. Okay, a couple of configuration about the exit server here, and creating the service. So this thing is basically just setting up the service for the exit containers. That's all. Service connections, perfect. Load balancer, this is very important because we're creating this load balancer where people are going to be going, and when you go to maccluster.rup12.net, you're actually hitting this load balancer, and this load balancer is going to be, well, distributing the traffic to these things. Okay, certificates, perfect. Creating a certificate, just make sure we have HTTPS enabled. And this is the client's listener. These are again something related to the load balancer and the inlets clients. Basically, creating a listener for them, setting up targets, more listeners, more targets. Basically, there's private and internal targets in here. More listeners as well, and finally, here is the new task definition. So this task definition creates the inlets that are going to be running on these servers. So actually, let me show this to you. So I'm going to go and I'm going to open up this. Let me zoom in. And what's the best way for me to do this? SSH darko at the I think this is the thing, yes. Okay, yes. So I am currently now, come on, you can do it. There's no neofetch, okay. So I'm currently logged into one of these servers, actually the one on the left side, the most left server. So if I do Docker PS here, you will see there's a bunch of containers on here. There's the agent, there is the inlets thing, and this is the thing. This is the actual task definition that's being run. This is the inlets container service task running that's going to be connecting this laptop to the inlet service running on AWS to basically this other one running here. If I show it to you here. To one of these two. I think it's going to the bottom two. Yeah, to one of these. Basically, it's creating a network connection between those two things. It's an inlets feature. Okay, going back to this. Adding containers. This is just basically just configuration, how that works. Specifically, it has to have a domain name so it can connect to it. It has to have SSL. I think it has to have SSL, but I'm making sure it has it. And also the license key, and the license key is basically getting it from Secrets Manager, and the token is also getting from Secrets Manager. These are just secrets being passed over to the container. Inlet tunnel, basically a bunch of other things here. This is a patch, and this is something created by Nathan. Still, there's no way to do this in CDK. And maybe I can yell at Adam here for a second here, but because this feature is still not available for an external service. So when you create something called like an external service like this, right? So you cannot set it up so it's a daemon. You just can't. There's no way to do it in CDK. At least I couldn't find it. So back in the day when Nathan did this, basically it was a patch. It was a way to kind of override this thing by using CloudFormation native commands. So yeah, there you go. Anything else here is just basically creating an application. This is the front-end application. The front-end application here in this case is just, what is it? So if I do CDK app, it's for Mike here, it's JavaScript. It's just great. It's just a little JavaScript application that shows, shows this, nothing else. It just gets this system information, prints it on screen, and that's it. Nothing else. It's basically what it is doing right here. It is so CDK app Docker file. It is just packaging all of these things in a little front-end application, and that's it. So when I actually deploy stuff with CDK, it packages it all up, pushes it to a repository up in AWS, and then it is deployed. You guessed it, to these boys, and that's it, right? so that application is actually running on there, and that's kind of it, right? So if I'm gonna show this to you, so if you go up there, you can go to repositories, and I'll give you a link here. How do I call it? It's called my cluster, I think. Yeah, my cluster project. I'm gonna post a link in the chat. So if you want to go and check out the code I used to see how I did it, and please note, it's not good. It could be way better. I just don't have time I didn't have the time to kind of make it really good. On top of that, I do have some Ansible code here, and the Ansible code here is, I'm actually gonna show it to you. So I haven't talked about Ansible because it's not kind of the priority of right now, but Ansible in this case, it is, let me show you too, Ansible. So Ansible is also infrastructure as code, but it is more to the configuration side. So what I'm doing right now here is using Ansible to configure these servers. Remember, these servers behind me are physically running locally. So if I want to go and deploy more of them or make changes to them, I actually have an Ansible template here, Ansible code that's going to install specific packages to them. Imagine this, it's a new system, I just installed Debian on it, and what do? Do I go manually and click buttons on it, or just run commands? No. This Ansible, this bit of Ansible installs the packages, it actually even installs Docker, it sets up some specific laptop stuff, it installs SSM for me, it also runs ECS Anywhere. Now, the ECS Anywhere part is kind of flaky, especially if you want to go switch endpoints, but it does really work. So if you want to go ahead and configure your laptops or your virtual machines using something like Ansible, it is all available for you there. Okay, so let me go back to this. Amazon ECS Anywhere. Why is this thing important, and why should you care? If you have a requirement, actually, if you have a lot of servers already available, so you have this whole data center of servers, but you still want to use the cloud, why not use it with Amazon ECS Anywhere? It gives you the ability to use the same control plane, basically the same interface. Everything that I showed you right now is AWS native, right? So let me go back to this. It is this, you would control containers on AWS and in your data center behind you in the same way as you would control them on AWS. But you want to utilize all of that capacity that you have locally, right? Or, I don't know, maybe you have a requirement that your application is only available locally, right? Imagine it's a factory floor, and there are a couple of applications that need to be running locally, and they need to be accessed locally, not through the internet, but only through the local connection. Yeah, that's the way to do it. You can manage those applications, you can manage all of those things through ECS Anywhere. Joe Perez is asking, any notes on the cost difference between hosting similar purely on AWS? So, it depends. really, it depends. Yeah. Yeah, so as Adam is saying here, the containers on AWS are running purely on AWS. So you're paying for either how long they run or your EC2 instances or whatnot, right? And in this case, I'm using these ones behind me. So like the cost of the compute is, well, non-existent, but there is a cost of managing them. So it's gonna be it's a very difficult way for me to say it depends. It really depends on what you're doing and how you're doing it. But yeah. So yeah, if you are looking to do something like this, if instead of having multiple different ways of managing containers, multiple different systems, multiple different control planes, using something like ECS Anywhere could be a good solution for you. If you have systems that run anything from Amazon Linux to Debian 10 and whatnot. So I see Debian 9 is no longer supported. I actually don't even know what OS am I running here. So cat, let's see. It's Debian 11. Look at that, yeah. And that's the beauty about Linux. You can run Linux on very old hardware. So there you go. That's it. If you want to go check it out, first go check out Nathan's blog post. Nathan has basically started all this. That's a really great way for to start. And of course, if you have Raspberry Pis sitting on the side, you can do the exact same thing with Raspberry Pis or whatnot. I happen to have a bunch of servers here with me, so you can go. I did it a bunch of laptops, but you can also do it with Raspberry Pis, which may be a smarter option to do so. But hey, if you want to go play around with this, I highly encourage you, even if it's just your virtual machines running locally on your workstation. So, if there's any more questions, I'd be happy to answer them. Feel free to post them in the chat. I think I'm done. I have nothing else to talk about besides how amazing Nathan's blog post is, and Adam does great things.
Cool, thanks, Doc. That was fantastic. So I'm just checking some comments. Yeah, seems happy.
Thank you,
You
folks.
want to add anything on the security side, Doctor? I mean, as a container guy myself, when we do ECS anywhere, the two things that comes to my mind is the maintenance, yeah, because you have to run your own thing, patching, all that. And the other thing is the security. So, what would your take on this, or Adam, you can add as well.
Yeah. So when it comes to security here, remember, everything here is happening, of course, through the internet, unless you have it set up differently, right? So all the control plane, all of the control, sorry, all of the, how would I call it? Basically, the control of applications is being done through the internet, right? But it is done in a very secure manner. So if I want to share my screen once again for a second. So
Yeah, go for it.
this. Look at that. Yes. So I mentioned this, that all of your instances are being managed by Systems Manager. And if I go here and see my inventory, you will see that I have, not inventory, Fleet Manager. You will see that I have a couple of instances being managed remotely. So these are all of my instances being managed remotely. So the great thing is, like, it's basically having an agent running there, and through the power of HTTPS, it is doing all of the management. So it is using secure protocols to do that kind of a thing. Now, you can further limit. Remember, the application running on this virtual machine is not accessible to the internet by any means. What happened on this virtual machine is that ECS just launched the application, and it just manages the application. So depending how you set up your VPN setup or inlets or whatever you want to, however you want to expose your application to the internet, that is completely on you, and you have the absolute choice to do that in any way you want. So,
Cool,
is it
thank
possible
you.
to access DynamoDB or S3 on your local machines? Are you talking about hosting DynamoDB or S3 on local machines? Is that something you're talking about? Because, well, you can't technically host those things. There's a way to simulate those things, but what was that? There was an open source project that kind of did those things. I forgot the name of it. If anybody here in the chat remembers, there was an open source project that would do those things. It would basically simulate a couple of AWS services, but it wouldn't run. Oh, just host it. Yeah, absolutely. So, no, for sure. So okay. So the question is, can you access S3 from this thing? Absolutely, you can. 100%. Right? There's no problem here. The thing even here, like I don't think I have the AWS. Okay, I don't have sudo AWS. Let's see. So I'm going to install the CLI here, right? Just command line interface. The thing is, this is my virtual machine. This is the Ubuntu VM running locally. So basically, the beauty about this is when this instance is managed. So when you see this instance being managed like this, so Ubuntu, there it is. It has a specific instance profile attached to it. That ECS Anywhere instance profile attached to it, and that gives it specific permissions to do things. So even though I don't have any permissions here, so there is no. Is there AWS folder? There is. There's some credentials here. I haven't configured them. I haven't added anything here. I should be able to do things. AWS S3LS. I can't do that. AWS STS get caller identity. You see, I'm actually running all the commands here as this specific role. Now, if this specific role has permissions to S3 or DynamoDB, I could absolutely do those things. So yes. The beauty about it is you are distributing credentials dynamically, so you don't have to care about setting up credentials manually or whatnot, but absolutely you can do that.
Cool, thanks, Darko. I'm just checking if there's any other questions from anyone for Darko. Or you can always catch up with the Twitch channel like this. Yeah, the Container of the Cloud. Yeah, you have a lot of shows going on. So yeah, you can obviously catch up with him.
You will find me on Twitch, on YouTube, on Twitter, or wherever you want. So I'm doing a lot more things these days. So yeah, any questions you may have, any type of stuff you want to talk with me, please do.
Cool, man. Cool. Thanks, Darko. I think then if there are no other questions coming up, I would welcome Adam to bring up in. So thanks, Darko, joining.
Thank you, Madhu.
Yeah,
thank you all.
I hope you get well soon. So thanks for sharing your knowledge. It's been great. Thanks, Darko. Bye. Cool. Welcome back, Adam, again. So.
Hey there. So first of all, I just want to say that Darko, you nailed the ECS stuff. You nailed the CDK stuff. 10 out of 10. Okay.
I agree.
It was really good. And there's just a couple of things I wanted to add that one of the reasons ECS Anywhere was launched was because typically prior to ECS Anywhere being launched, if you wanted to run containers in the data, like in a data center, in a facility, right? Like you wanted to run them somewhere, you needed a way to orchestrate them. So oftentimes that meant you're running the orchestrator on site, which requires maintenance, management, scaling. There's a lot of considerations that go into that. Well, with ECS Anywhere, you get the ECS control plane, which A is free and B is fully managed by AWS. And remember the control plane and cluster orchestration, this is kind of the brains behind when you want to launch a container and run it. And you have a set of instructions defined in your manifest. The orchestrator's job is to make sure that the desired state of that application running on that container is going to be met at all times. So imagine with ECS Anywhere, I don't have to manage an orchestrator. But I want to run in my data center or like maybe I have an office, an office location where we want to run some of our applications. ECS Anywhere, you just bootstrap your servers on site, connected to ECS Anywhere, and boom, you're ready to go. You're not managing an orchestrator. So it's super beneficial for those that just want to get their applications running, not worry about all the heavy lifting that comes with managing a container orchestrator. So I just wanted to add that. Madhu, is there anything else you wanted to touch on before I dive in?
No, I think that thanks for the added comments. I think I will go in the background and stage is yours.
Perfect. Thank you. So first of all, thank you everybody, for being here, for having me. Thank you, Madhu, for having me here. I'm really excited to be here. So today I'm going to talk about, so I'm going to start with the PowerPoint. I usually prefer to just dive into demos, but I thought it'd be helpful to kind of lay out a little bit of context and kind of set a foundation of talking a little bit about infrastructure as code, the AWS CDK, and then, kind of walking through what a typical container build and deployment workflow looks like. And then we're going to dive into a demo and show all the good stuff. So with that said, so just a little bit about me. My name is Adam Keller. As I mentioned earlier, I'm a senior technologist here at AWS. I have been working in DevOps, systems engineering, development, software development, software engineering, cloud automation for over a decade. I previously was a platform architect. I led DevOps teams. I am just someone who is super passionate about, when the DevOps movement came about, I just felt like, I was like, man, this is me. This is where I want to be. And so I was actually very fortunate to be I was kind of at the birth of the DevOps movement. I was there. I got to see it grow. I got to see a culture it become a job title, which, I know it's always a joke, but like, we say like DevOps is not a job title, it's a culture, and you have to practice DevOps. But anyway, little joke there for those who are familiar with that. But I have worked with all sorts of technologies, and I've built and managed container orchestrators at scale, serverless architectures at scale. I'm a huge fan of AWS Lambda, DynamoDB. Just, really my goal whenever I am looking at building an architecture or building environments is I'm not looking to use the latest, coolest technology because it's going to help my resume, even though maybe I should. But really what I'm looking at is how can we build in a way where our operations teams or DevOps teams or SRE teams are not overloaded with a bunch of, maintenance work and constantly catching up, but they're actually focused on building architectures that are meaningful for the business. And on the flip side, where developers can focus on writing applications and ensuring that they're meeting the business needs at the speed that they need to compete and be successful. So I've led many migrations into the AWS cloud, as well as just designed and built new greenfield architectures from the ground up. So I've been with AWS for a little over 5 years now, and previous to that, I've worked at startups, and one was successful, one not so much. The startup game, it's a hustle, you hope, and so I was lucky to see one make it over the finish line, and the other one not so much. But honestly, great companies and great experiences. And I've also worked in enterprises and Fortune 500 and companies that had a lot of regulations, PCI, HIPAA, all the things that you need to be cognizant of when you're building and designing. If you want to reach out to me, please LinkedIn. This is my username. Twitter. I don't tweet as much. Or X, I should call it, I guess. But GitHub also. I didn't put that link on here, but my GitHub is Adam J. Keller. So feel free to reach out to me anywhere. CDK Live. So Darko had mentioned, containers from the couch. We saw them in the chat. I was lucky enough to be one of the folks that helped launch Containers from the Couch a few years ago. And now recently I launched CDK Live, and I'll talk more about that in a little bit. So I want to start very foundational. So if you know what infrastructure as code is, I'm sorry, feel free to just go get some coffee for the next 30 seconds here. But, what is infrastructure as code? When I think of infrastructure as code, essentially it provides the ability to provision and support your cloud resources programmatically using code instead of having to provision resources in the console. So, we'll talk a little bit more about what that means right now. So, I want to tell a little story. I like to always kind of paint a picture, and I'm sure some folks can relate to this, but any application environment is going to require infrastructure components. You're going to need, virtual machines or containers, or you want to run on serverless compute. You're going to have to connect to databases. Storage is going to be needed. Maybe that's object storage and like S3. Maybe you need a shared file system. Maybe you need a relational database, and all of the maintenance required can start to add up and start to pile up. So developers or operators are thinking about setting this up, updating it, maintaining it, in order to ensure that developers can move at the pace that they need to move to get their applications tested and deployed, bug fixes, and to make sure that they can get those out as fast as possible. So when you're testing out new things, the AWS console is really good, and I want to make sure that it's understood. There's a million ways to build your resources in the cloud. And there's not one right or wrong way. I would just say that there's some ways that are more optimal that are going to make your life easier. But when you're testing and trying new services, definitely creating resources, testing them out in the console is a great way to get started, because this is how you're going to learn about a service. You're going to understand. It's going to have a good walkthrough for you and to get you where you need to go. However, as more and more folks start to jump into the console, they start provisioning resources, it becomes a little harder to track who owns what they did, and if someone actually accidentally modified your resources, it becomes really difficult to manage this as more hands are in the cookie jar. So this just ultimately becomes exponentially harder as more and more people are in the console. It becomes harder to maintain and manage. So when you get to this point, you're also going to need to create multiple environments, right? You don't want to couple your test resources with your production resources. And if you're familiar with AWS, you've seen some talks, you've probably heard this, but you want to have that isolation. And generally for test environments, you want to keep those isolated in their AWS account, and then keep production resources isolated in their own account. And the idea is, if there is something that goes wrong, if someone makes a mistake, which we all make mistakes. One of my favorite stories was I started at this new company a few years back. I was so excited. I was young into my career, and I got a simple ticket. I'm like, oh, great, this is easy. I just got to change a configuration value. Well, it wasn't that easy, because I changed the configuration value, and I just deployed it to prod, brought down our production application, big outage. Anyway, it was fun, but I learned from that. And I think we all need to understand that mistakes are going to happen, but if we can limit and try to isolate as much as possible, we can at least limit the risk for making those mistakes, and we can try to make those mistakes in lower environments before they come up to production. And of course, we don't have to mix things together. So what happens when you get to this point where you've built your test resources, now you want to deploy them to prod? If you're working in the console, you have to remember every single thing you did, right? You have to know that, okay, I created this Lambda function this way, this DynamoDB table this way. I have an IAM role that's attached to my Lambda function. I created a policy to allow it to access. I can go on and on. So when it comes to reproducing that, this is where building and maintaining resources can be very challenging when you're doing it in the console, because you have to reproduce that. And we're always going to forget. If you're like me, your memory is going to forget that within a matter of seconds. I am telling you, I build something, a week later, someone asks me about it. And if I did it in the console, I have no idea what I did. But if I did it in code, I at least have a place where I can go look at, especially if I'm using Git, which is a good practice. I can see my commit message, which says, I did this because I needed this. And then I can hit the ground running and figure out what I need to figure out. So manual infrastructure management is very time consuming and prone to error, especially when you get to a scale. So this is where infrastructure as code comes in. So infrastructure as code lets you define and track your infrastructure's desired state without including all the steps to get to that state. So it automates the infrastructure management, so operators, developers can focus on building and improving applications instead of managing these environments. So by leveraging infrastructure as code, this can control costs, because you can have a consistent tagging experience across all your resources. It reduces risk because I know my desired state is stored in code, and I can always see what our intent was in our code base. And ultimately, when new use cases come up, you can just write your code, deploy, test, and rinse, repeat, rinse, repeat. Okay, so we're gonna talk about now, and Darko mentioned Ansible earlier, which was actually really cool to mention, because infrastructure as code has evolved over the years. And Ansible is one of those tools that this was really big back in the configuration management days. We had to manage servers a lot, when virtual machines, physical servers was the way that we ran our applications on top. It required a way to build in a repeatable way. And this is where configuration management was a big thing. So Ansible, Chef, Puppet. If anyone remembers those tools, give me a shout in the chat. They were wonderful at the time, did some really great things. But anyway, I just always have memories of those tools, because those kind of fueled the DevOps movement as well. So when this all started, it was manual deployments. So we used wikis, we had playbooks, SOPs, standard operating procedures, and oftentimes, we'd go to reference these documents, and they were outdated. And we know maintaining documentation can be hard, especially if it's not in some sort of automated way that can read your code and then present that. So we relied on, if it wasn't the documentation, oftentimes it was Jim and Nancy, and Jim and Nancy were the two that knew everything about our environment. And if Jim wanted to take a vacation the same time as Nancy, we couldn't allow that, because if they were gone and something went wrong, we were toast. So we relied on these individuals and these documentation to keep up to date, and ultimately it just became a bottleneck, and this was very hard to maintain. So then we realized this doesn't really work. So let's automate, which is great. I'm a big fan of automation. If you like to automate things, you like to write scripts, this is great. But what we found quickly was automation, writing bash scripts, maybe it was PowerShell scripts. Perl was a big one too back in the day. This worked in the beginning, but what we saw was things got complex, and they got complex fast. And while, again, the folks that wrote the scripts, maybe it was that one or two people that wrote those scripts, they had a good idea of where to go. But when you had to come in to maintain that script or to add a new feature, it becomes almost impossible to read and to understand, because these bash scripts can be thousands of lines of code, and it's very hard to understand when you start to get that complex. So it got to a point where folks were frankly just too scared to touch them. And this is where we kind of realized we need a change. And this is where the next big innovation came in. And this revolutionized how we built and manage infrastructure or resources in the cloud. And this was to use native infrastructure management tools that would provision your resources, like AWS CloudFormation, which I'm sure folks are familiar with, as well as HashiCorp Terraform. These are two very big, commonly used tools. Now, these tools took care of really the most important part of managing your resources at scale. And what you saw in my previous diagram, which was that state management. Because when you had to manage things via bash scripts, you have to be considerate of the state of those resources. So you have to write a lot of conditional logic to figure out, if this resource exists, don't create one, use the update command, update API, and do this and this. So these infrastructure as code tools take care of that for you, because they manage the state. So, with Terraform, you as the user, you're responsible for managing where that state file lives. But if you use tools like Terraform Cloud, they can help manage state and so on. And with CloudFormation, state is fully managed within the CloudFormation engine. But these tools, by taking care of that, they enable builders to have rollbacks. So if something failed, it could roll back to the previous state. It could also detect drift. So this is a big one, because we preach for code automation to deploy your resources, but as we know, there's going to be people that have to go into the console to do things. It happens, someone makes a change, and then now our what we've defined in code and set our desired state differs from what actually lives in our cloud. So this is where infrastructure as code tools really help make a difference. And in addition, they provide a way to, when you're building and deploying, to give you really good error handling and error management to understand what goes wrong and how to fix it. So the developers would, generally with these tools, you're describing your infrastructure state using a declarative language like YAML or JSON, which JSON also works for Terraform. But generally with Terraform, you use a domain-specific language, which is called HCL, or the HashiCorp language. And then you take this code, this desired state, you hand it over to the deployment engine, and that's going to be Terraform or CloudFormation. So this simplified a lot of the infrastructure management process. However, as we started to grow, what we found was it became harder and harder to read as your YAML or JSON started to grow. So Terraform does provide a great way to modularize your code so you can split this up. But as this grew, what we found was it was just more challenging to troubleshoot, to read, and also to just build general programming concepts on top of these tools, to leverage like classes and methods and so on. So this had it, and then, oops, this is where generators came into play. So tools like Troposphere, GoFormation, these tools allowed for developers to, developers or operators. By the way, I say developers here, just keep in mind, this is in the context of, this could be like an application developer, could be someone on an operations team, DevOps person, SRE. I just say developer, think of it in a broader context here. So these tools came out and they were really great because what they did was they allowed for users to use a general programming language to define their resources in CloudFormation. However, this ultimately became a challenge as well because you still had to be an expert in all of the underlying infrastructure, defining all the resources, connecting resources together. And this is where we saw the birth of what I like to call the next generation of infrastructure as code. And this is where you see tools like the AWS Cloud Development Kit, Pulumi, and so on. And what these tools do is they provide a framework for you to create custom abstractions for cloud infrastructure. So let's talk about, and by the way, do that as leveraging a general programming language of your choice. So what is the AWS CDK? So now I want to talk about the Cloud Development Kit. What is that doing? And I like the, you always got to ask Bob if he knows is my favorite deployment strategy. I agree, Darko. Just give it to Bob. Let me have my coffee and just relax. Okay, so when we talk about the Cloud Development Kit, this is it's an open source software development framework that allows you to model and provision your cloud resources using familiar programming languages. So what's neat is with the power of the CDK and one of its underlying libraries called JSII, it allows you to define your infrastructure as code resources using a familiar language. And there's a choice you have. So there's Python, which Mike, we support Python. So we got that going. TypeScript, JavaScript, Java or C#, as well as Go. Now, I will tell you what we see out there is a lot of folks are leveraging TypeScript and Python. I think it just goes to show you that these are really popular languages, easy to get started with and kind of jump in and get going. But by using familiar programming languages, you can actually leverage all of these concepts that you're familiar with when using these programming languages. Classes, methods, inheritance, and especially, I would say probably one of the big ones is control loops, like leveraging native for loops, conditional statements. This has been, these programming languages have been out for a long time. This is just very native to what they do. So it's just really built in and makes it a lot easier. You can also leverage all of the support you get from these programming languages, such as autocomplete, inline documentation, unit tests, integration tests, which is a big one, linting, and debuggers. So most people hear this and they think, this is pretty cool. I like this. But I don't know, I can just stick with a declarative tool. It's a general programming language. That's neat. Now, that's not the only thing that makes the CDK really great. And I would say this is just the tip of the iceberg for the CDK. The true superpower of the CDK is that users can take advantage of the abstractions provided from this tool. They're packed with same default values and helper methods to simplify the authoring experience. So I'm going to go into this, but I want to just give a quick example of what I mean when I say that. So when you're defining, you build a Lambda function. Actually, let's go with Darko's use case. So Darko created a container image. He created an ECS service. And then someone had asked, can my service running in ECS anywhere, can that container access something in S3 or access an S3 resource or a DynamoDB table that exists in the cloud? Well, traditionally, if you're using CloudFormation, or Terraform or one of those tools, you have to define the IAM policy. You have to create the role, attach the role in your code to that ECS service, make sure that the permissions are correct, and so on. With the CDK, they have helper methods such as the grant read, grant write, grant read write methods. So all you do is you create that service, you do a .grant read, and you pass in the object of that DynamoDB table, let's say. And the CDK behind the scenes is actually going to create that IAM policy. It's going to attach it to the ECS role, task role. And you don't have to worry about authoring all of that extra code because the good practices are baked into the CDK. So these are all really helpful. But of course, as you start to build, this is a very common thing with opinionated tools. As you start to build on them, what you find is you outgrow the defaults, right? You outgrow the opinion. And the beauty of the CDK is you can build on top of these defaults, modify them, and really build to support your use case. So you can go beyond the defaults and configure your resources to work as you need. Another common practice we see with the CDK and what makes it so powerful is the ability for companies to build their own abstractions. So users can package their own organizational best practices into these reusable libraries. We call them constructs in the CDK. So from this point on, I'm going to start calling them constructs. I may go back and forth between libraries and constructs, but you can create these constructs and then share them across your organization. So a very common practice we see is folks create, we want to enable developers in our org to create S3 buckets, but we need to make sure public access is disabled. Yes, you can have a service control policy that can do that. There's so much you can do outside, but you want to make sure you have that control within the construct. So public access is disabled. I want to make sure a KMS key is created that we own, and that bucket's encrypted with that KMS key every time a developer creates a new S3 bucket through the CDK. So you can bundle that into a construct, call that my secure organization secure S3 construct, share that, push that to an artifact repository, code artifact in AWS, Artifactory, whatever you use. And then developers can use that and have that simple way to deploy that bucket with all of your organization's best practices built in. Okay. Promise you I'm not going to do too many more slides. I promise you I'm going to get to a demo. So don't feel like I'm leaving you hanging here. So what does it take to get from a container image on my laptop that's running to serving real traffic using the CDK? Let's start by looking at a typical container workflow, and then I'm going to show you how it fits in with the CDK. And not only that, I'm going to show you how the CDK simplifies the overall build, test, and deployment process in one single place. So we always start with our container image. This is our Docker file, right? We need to build that running our commands, docker build, -t, image name and tag. We test it, iterate, keep rebuilding. And then when we're confident that we want to now see this running in an environment in one of our orchestration clusters, or maybe we want to run it on Lambda, wherever that is, we now need to push that image, right? So now this is where we have our Docker push, right? So if you're using Docker or Finch, by the way, I'm a big fan of Finch. If you haven't checked out Finch, that is it's AWS's open source way to build and manage container images locally. And I believe Mac OS is the only supported operating system right now. I could be wrong, but check it out. It's just under AWS, it's Finch. I'll share a link for that in a little bit. But so now you need to push that container image to your registry. So in this case, I want to use ECR. I need to authenticate to the registry, and then I'm going to push that image to that registry. Now, this registry, though, could be Docker Hub, could be whatever registry you're working with internally at your organization. So the final step of our process is we need to deploy our application. We have to deploy this container to our orchestrator. So first we have to define our manifest. In this case, I have an ECS task definition. This is defining, how to deploy, what my desired state of my container is at runtime. So this is like, what port do I want to run? How do I want it to log? Does it need a load balancer? Am I using Fargate, or do I need to run this on EC2? Do I need a file system attached, like an NFS system using like EFS? This is where I'm defining all of those details, and then I'm going to deploy it. So in this case, if I'm using ECS, I need a way to deploy my container image to the orchestrator for the orchestrator to ensure that my desired state's met. So again, I tell the orchestrator, here's my requirements for this container to run, and I need to make sure, container orchestrator, that it is running 5 instances of my container at all times. So in the case of ECS, it's running 5 tasks at all times. And the job of the orchestrator is to make sure that that happens. So if one of my tasks goes unhealthy, too much traffic hit it, something happened, the orchestrator is going to actually replace that task and with another healthy one to serve traffic. So this can vary depending on the orchestrator you use, the compute you use, and so on. But this is our general container orchestration workflow. So as I mentioned earlier, with this build process, we need to have a container image build process. So usually what we see folks doing is you're going to have a pipeline. Maybe it's a CI pipeline that's going to run a Docker build, Docker push. You have to manage that pipeline. You have to think about this like aspect and this component of your workflow. So with the CDK, we actually can leverage the assets library. And assets in the CDK can be local files, directories, or container images that get bundled into your CDK application, and they can represent any artifact that your application needs to operate. So what's really cool about this is users can couple their infrastructure as code definitions as well as their manifest definitions for, and I'm going to kind of preface this with most commonly, this is with like Amazon ECS, App Runner, Lambda. Again, Lambda is not a container orchestrator, but you can couple your infrastructure code as code, your deployment manifests with your deployment manifest all in the same place, all within the same CDK app. So let's look at an example. So, I have my Docker image here on the left. My run command to install some dependencies. I have my requirements.txt. Hey, Mike, there's your Python, by the way. We got it. We did it. And this is where I define my requirements. So that's my Docker file. Now, on the right, what you'll notice, I don't have a build script. I don't have a pipeline that needs to, I don't have to define this process as some shell script somewhere. What I'm doing is I'm leveraging the asset library, and I'm just simply passing into the library, here's the directory where my Docker file lives. Now I want you, CDK, to build my Docker image. I want you to deploy it to an ECR repository, tag it, and then eventually when I want to deploy it to my orchestrator, I want you to reference that image, make sure the permissions exist, and so on. We'll get into that in just a moment. But what we can see at this point is the CDK has removed the need for me to have to create these scripts for the build push process to that container registry. I don't even have to create that registry in ECR. The CDK handles all of that on my behalf, and it basically changes the way you think about your container images when you're building and your containerized applications, because now this becomes an implementation detail of the CDK, and I don't have to think about that. All I'm saying is, here's my Docker image, you take care of the rest. So let's now talk about how we can take this from the CDK image, building my asset and pushing it to the container registry, to deploying it to an orchestrator. I like that. So, of course, there's various ways to run containers. Darko mentioned 17. I know that the truth is there's really only a couple ways to run containers in AWS. There's ECS, App Runner, and EKS. EKS is our managed Kubernetes service. So, and you can also deploy a container image as your application artifact to AWS Lambda. But again, this is the last time I'm going to say it, because I think I've said it like 10 times already. I know I sound like a crazy person, but Lambda is not a container orchestrator. But you can package your application using a container image, which Lambda can use as that artifact. So with Amazon ECS, generally you have your task definition. And this task definition, as I mentioned, defines your requirements for the desired state of your container to run using that orchestrator. So the ECS control plane receives these instructions and then ensures that it's running as you expect at all times. So because we were able to define that build process in the CDK using assets, all I have to do here is leverage one of these higher level constructs, which I didn't dive into. Actually, I'll dive into that when I demo the various constructs of the CDK. But what I'm doing here is I create my task definition and I'm adding a container. So, I'm passing in this from asset property, which is going to look in that summary app directory, which has a Docker file, going to build it, and then it's going to make sure that my container when it runs, which is actually when my task runs as an ECS service, that it knows to pull this image from this repository with this tag. So that's all managed and handled through the CDK. Then there's AWS App Runner, which again, Amazon ECS is a fully managed container orchestration service. ECS, you can run your containers when it comes to, you have your control plane, which is fully managed by Amazon ECS. You create clusters in ECS, but think of those clusters as just logical pointers to where you want to bound all of your particular tasks to, based on an environment, based on an application type, and so on. So really the clusters are just organizational. The control plane is all managed behind the scenes and completely abstracted from you as the user. And then you have your compute that you can run with ECS, which is either EC2, Fargate, which is our serverless compute engine. And then, of course, there's also ECS Anywhere, which Darko had demoed earlier. With App Runner, this is a fully managed service where you can just define either your container image or just your application configuration through like a spec file. And App Runner manages the build, the deployment, it can manage the build, the deployment of your application, as well as the scaling of it as well. So think of App Runner as a really everything's managed behind the scenes. All you do is say, here's my code, App Runner, here's how I want you to scale, you handle the rest. So ECS, you have more control over how you scale your containers, and so on. So what you see here is, again, I am using this asset property to deploy my Docker image and then connect it to my App Runner service, and everything else is handled. Now, I mentioned earlier that the more common workflow when building your container images and deploying them to container orchestrators through the CDK is generally through, you generally see it with ECS, App Runner, Lambda, but you can also use the CDK, use a programming language to define your Kubernetes manifests. So there's an open source project called CDKs. So CDKs is, again, it's an open source development framework that you can use for defining your Kubernetes applications, and you can build reusable abstractions using familiar programming languages. So one thing we know about Kubernetes is there's a lot of YAML. And that can be challenging as your manifests grow and get bigger. It becomes harder to read this YAML, especially when you want to start making your YAML a little more dynamic. You want to start, kind of programmatically making decisions. There are tools like Helm and Customize out there that can help, but there's a learning curve. It requires you to learn these new tools to get started and to get familiar. So with CDKs, you define your application programmatically, and there's also CDKs Plus, which provides a lot of abstractions, these higher level abstractions for you to build on common Kubernetes concepts. So when you use CDKs, you define your manifest using your programming language, and then when you synthesize your code, it will output the YAML files, and then you can deploy those manifests however you see fit. So this is if you were using GitOps like Argo CD or Flux, you can take that manifest, commit it to a Git repo, or you can even have this as a build process and then have it automatically commit that to your repo, and then Flux would automatically apply that manifest and to meet desired state. Or you can, if you have a build process of your own that runs kubectl deploy, kubectl, whatever you want to call it, you can do that as well. So, or Helm, you have a lot of choice here. But the main difference between the two is that CDKs is really just focused on building your Kubernetes manifests and applications through code, but you still you have to think about how you want to deploy those manifests. Whereas the CDK has the CDK CLI, which can deploy those resources on your behalf to tools like AppRunner, ECS, orchestrators like those. And the last thing I wanted to mention is AWS Lambda. So AWS Lambda is not a container orchestration service, rather it's a serverless compute service, and it lets you run your code without having to provision, scale, manage servers. So personally, this is my little tangent, but like anytime I'm building in AWS in the cloud, I'm thinking of first, can my application run on Lambda? Because ultimately, Lambda is going to give you the easiest path forward from a management perspective. You don't have to think about scaling. It just runs and launches when you need. But of course, there's things you have to think about. There are considerations. But if somehow Lambda doesn't work, that's okay. Then I would move to AWS Fargate or AppRunner as the compute to run my service. Again, serverless, I'm not managing the underlying infrastructure to deploy my containers. And then as your use cases become more complex, ECS does support EC2 and has a feature called capacity providers that can manage the scaling of the underlying EC2 instances. And of course, if you're just a Kubernetes shop, then maybe you want to just run EKS. So with Lambda, you do have to define your container image in a unique way. You have to use one of the Lambda provided images, because there's essentially Lambda expects the image to have certain libraries installed. So every time the Lambda function invokes, it can serve your application as it expects. But again, same process. I define my container image. I use the from asset image property. CDK is going to build it. It's going to push it to ECR and then connect that Lambda function to that container image artifact. Whew. Talking a lot. So that essentially is our container image workflow. And what you can see is all of this work that we normally have to do in a pipeline and build on our own, the CDK can manage that as implementation details of the CDK through simple abstractions, these higher level abstractions, these libraries that make your life a lot easier. So all of these things we discussed can be handled through a couple of libraries that you call. You build it. CDK will build it, deploy it, push it, manage the state of all of your infrastructure using CloudFormation behind the scenes, and they take care of that for you. So next, I'm going to dive into a live demo. But before I do that, I feel like I have to do a shameless plug here. So, we mentioned earlier, we had, well, I launched Containers from the Couch a few years back, and we just recently launched CDK Live. So, very new channel. We already have a few videos up, a couple live streams, but we're going to continue to grow this channel. And I urge you to, if you're looking for any content related to infrastructure as code, CDK, CloudFormation, and so on, please check it out. You can hit that QR code there. Subscribe to the channel if you're interested. I don't want to push, but if you want to get updates, feel free to subscribe. But this is where we're going to be to date on anytime there's a really big launch in the CDK. We're going to have a show about it. We're going to talk about it, answer questions live. And also we're building tutorials. So, one thing that folks oftentimes struggle with, and it can be common with the CDK, and frankly with any tool, is getting started. It can be challenging. So we will have a getting started section and a walkthrough on the various programming languages as well. So all of this coming soon. Also, if you're going to reinvent, reach out to me on Twitter. Reach out to me on LinkedIn, GitHub. Not GitHub. You can't message on GitHub. What am I saying? But reach out to me, and if you want to meet, talk about anything, cloud related, CDK related, containers related, Lambda, sort of whatever you want to talk about. I love to chat. Honestly, this is just something I'm super passionate about. I love what I do. I love the technology, and I love to talk about it. So, anyway. Check out the channel, give it a subscription, smash the button, and yeah. Okay, live demo time. So for this demo, I have built a Wikipedia API application. I'm using Python's Fast API. I use a Wikipedia library, and essentially what this application does is you just send a post with your search term. On the back end, it's going to search Wikipedia and then provide a summary of that search term from Wikipedia. So what I want to do is I want to use the CDK to build that image, and then I want to deploy that image to Amazon ECS. I want to use AWS Fargate because I don't want to manage the underlying servers that my containers are going to run on, and that's where AWS Fargate is amazing because all I have to think about is my container and how do I want to scale my container, and let's do it. So let's get out of this PowerPoint. I can't believe I bored everyone with a PowerPoint. Let's see. Hopefully, time-wise, I'm good. I kind of lost track. Please feel free to tell me in chat if I'm being a madman here and I'm talking too long. So I'm going to bring out Visual Studio Code. There it is. Okay. Is it? Let's see. We're going to do this, and we're going to bring this here. Okay. Wait a minute, is it here? Look at that, it was here. Okay, all right, so I have my Visual Studio Code here. I'm gonna zoom in a couple notches. Hopefully folks can see okay. If there's a problem, of course, let me know. So to get started, I'm going to use the CDK CLI. So I'm gonna use TypeScript today. Sorry, Mike. But you can use Python. As I mentioned, you can use Java, which, cool. You can use Java, you can use C#, Go. I'm going to use TypeScript today. It's just become a language that I've become very fond of over time, and I really love Python. But for some reason, TypeScript kind of won my heart over these past few years, and I give credit to the CDK for that. Okay, so what we're going to do now is we're going to install. So we're going to I have it already installed, but I'm just going to do this anyway. So I'm going to do an npm I install, and I'm going to say AWS CDK. So I'm going to install the CDK CLI. And I did G, which is a global install. So now I have the CDK CLI available to me. If I do CDK -- version, I have CDK running. Let's see, what version of NVM node am I using? I'm a little old here. So NVM ls, NVM use default. Let me make sure. Okay, CDK version. Oh, you know what? There we go. Perfect. So I have my CDK CLI installed. We're ready to go. So I'm going to run a CDK init, and I'm going to pass language flag of TypeScript. Now, again, if you wanted to use Python, you could use just pass in --Python. So now what it's doing is the CDK is going to give me what I like to call like a skeleton framework here. So it gives me basically everything I need to get started and to get moving. So I have a package JSON, which has the dependent libraries that I need to run the CDK. The CDK is a mono library, so all of my libraries that I need to access are going to be under the AWS CDK lib package. And then I have my lib and my bin directory. So when we talk about the CDK, it all starts with the CDK app. So your CDK app essentially is the application that encompasses everything needed to deploy your infrastructure, your application artifacts, all bundled into that app. And then within an app, within a CDK app, you have stacks. These stacks represent a CloudFormation stack. So essentially that stack is where you're going to define all of the infrastructure, all of the resources that you need for your application to run, for your infrastructure to run. So I'm going to clean some of this up here, and let's just pass in one thing, because I want this demo to be somewhat quick, because when you build a VPC, that can take some time. So let's see, is that it? So let's just do this really quick. All right. So we're going to pass in an environment. Also coming up on, so we do have on CDK Live YouTube channel, we have a couple of channels there. One, I have a deep dive into CDK assets, right? All the things I just talked about with building container images and so on. Check out that video. I also have a video on building or what constructs are in the CDK. So check that out on CDK Live as well. So I'm just going to pass my environment in here. And this is going to ensure that the CDK will deploy to this account in this region, this particular app. Another thing to note is when you launch CDK for the first time, you have to run a CDK bootstrap command. That CDK bootstrap command is just going to, essentially, I'm not going to go too deep into it, but it creates all of the dependent resources that the CDK needs to deploy your infrastructure as code. Okay, so now we're going to go into the lib directory, and this is where we have our generic stack definition, okay? So what you see here is, let's see, what did I do here? Did I open up the right thing? Apologies there. 1 second, just do this. Make sure I have this. There we go. Perfect. Okay. So the first thing I want to do is I want to install some of the libraries I'm going to work with. So I'm going to first install the ECS library. I'm going to install the ECS patterns library. And by the way, if you notice all this beautiful code completion, I am a huge fan of AI code companions. So there's two out there right now that you can check out. One is Code Whisperer. That's AWS's AI coding companion. And there's another one out there called GitHub Copilot. Both are really awesome. But essentially what it does is generative AI, it actually gives you code suggestions, and it's not always going to get it right. It's not 100% perfect, but it saves a lot of tedious work because it can give you some, you essentially give it you tell what to do. So like I could say import SQS library, SQS CDK library. Let's see if it works. Boom. And it gave me a suggestion there. So that's a simple example, but it can help you a lot. So I definitely recommend doing this. Import as, see, and again, using the IDE makes my life really nice. Okay. So what I want to do is I'm going to start by, we have a VPC, but what I want to do is I'm going to import a VPC. Let's see. So I'm going to also import the EC2 library, which is where the VPC construct lives. So let's do VPC equals EC2.VPC.FromLookup. Okay, so remember I mentioned those helper methods. So typically like if you're using like another tool, you'd have to figure out how to import some additional resource, right? Like, so the VPC, I'd have to use that as an input, manually pass it in, something like that. What I can do with the CDK is use this from lookup command, and I can pass in parameters. And you can see here are the options available. What I want to do is I'm just going to pass in the VPC ID, which I have saved. Let's see, I have that right here. And what will happen is the CDK is going to find this VPC ID, and I'm going to be able to work with this this VPC construct throughout my code. So when I launch my tasks, my ECS tasks into my VPC, the CDK is going to be able to grab that ID and make sure that we can deploy to the proper VPC. So that's my first step. The next step is let's create an asset. Okay, now, because we are going to use, we're using ECS, I'm going to use a library that helps make, that makes building these assets a lot easier, and that works directly with our ECS constructs, okay? Keep forgetting that as, but again, the IDE saves me again. So let's go and create an asset. So we're going to say const asset, and then we're going to say new ECR assets dot. Now I have a choice here, so I'm going to use a Docker image asset, and here are my options available. So the only required input here is the directory. So also what I want to do is import the path command to make sure. Look, did you see what it just did? This is why these commands are so cool. This is why these coding companions are so cool, because it knew I wanted path, and it just imported it because it was able to derive that from based on what I was doing. It was able to give me that suggestion. VPC ID, how do you get it? Okay, so good question. In this case, I just created a VPC, so I have that VPC ID. I could also, by the way, if I wanted to, I could use CloudFormation imports. So I could do import value from VPC ID, or if I had an SSM parameter, like they're really a good practice when you're building distributed applications, and depending on like the domains and who owns what, that VPC ID value is probably going to come from somewhere else. So you can use a CloudFormation import. So like usually it would be like VPC ID dot, dash development environment or something like this. And what this will do is it will grab that VPC from a CloudFormation output based on that value name and then bring it in. I could also create a new VPC if I wanted to here, but again, the reason I'm not is just for speed. But also, I could use an SSM parameter. Personally, and this is something I won't go too deep into, CloudFormation outputs, when you're using CloudFormation exports, there can be some challenges when they change if you have dependent resources, because they are immutable. You have a dependency. They can't be changed if there's something dependent on them. So you'd have to create a new resource. It becomes challenging. I personally like using SSM parameters. So I could also import from a string parameter, and the CDK CLI would call SSM. It's going to grab that ID based on that parameter and then import that proper ID and give me that VPC. So I hope that answers the question, but essentially, let's go back here. So again, the idea here is the CDK is super flexible when you're building and defining the resources. So what I'm going to do here is the directory. Let's see, I'm going to join, I have, and I'll show you the application in a minute. And what is it? It's Wikipedia. Let me see. Actually, let's do this really quick. So Wikipedia API. So my directory is Wikipedia API. Now, this is all I have to do. I am telling the CDK, here's where my Docker image lives. And when you go to, let's actually Vim, Wikipedia API, and then let's just look at the Docker file. Okay, so my Docker file, I have pulling from my upstream image. I'm exposing on the proper port. Here's the work directory. Here's what I want you to run, and so on. And in that directory is where I have all my code, everything needed for my application to run. So all I'm doing is telling the CDK, look at this. Here's the Docker file. Go build it, push it to ECR, and store that asset for me. Okay? So that's our asset. So we've now created our container image asset. And actually, you know what I'm going to probably need to do? Let's see if I may have to pull my screen away. Yeah, my credentials expired. That's okay. I use dynamic credentials. Highly recommended, folks. If you are, building locally, doing things from your CLI, please make sure you use dynamic credentials. Don't hard code credentials. It's just a recipe for disaster. You don't want long-lived credentials. Everything should be temporary. So if somehow you do make a mistake and someone gets it or something, it's not long-lived. But anyway, I'm off screen here for a moment just so I can do that. So give me one moment here, and then I'm going to do this, and then we're back. Okay, we're back. And I think we can see my screen. So how can I link the S3 directory to the work directory, the container? Could we elaborate on that question a little bit? Yeah, if you could elaborate, I think I may know where you're going, but if you could just elaborate a little more, and I'll definitely, I will most certainly get to that question. Okay, I went to the wrong one, didn't I? Oh, Adam, just a crazy person here. All right, here we go. I'm just being a crazy person. Okay, CDK diff. Did that work? Let's see. That should work. Sometimes technology doesn't work. There we go. Okay, we're back. We're back in business. Okay, so what I have right here is I ran a CDK diff. CDK diff is a way for me to, the CDK CLI will basically run a change set. It's going to check the difference between what I have deployed, if I have anything deployed, versus what my proposed changes are. So let's see. What does container tagging look like in the scenario, and how can we use it? And how can the CDK be utilized from the across accounts? Really good question. Okay, so the question was around tagging. So how does tagging work here? So I mentioned earlier, this becomes an implementation detail. The reason I say that is because you don't have to think about the build process anymore, and the CDK is managing the building and deploying of your assets. So if you're using, and I don't want to get into too much detail here, okay, so I'm going to try to be very high level with this. But the way it works is when you bootstrap via the CDK and you bootstrap your account in your region, that creates a bucket and an ECR repository. That repository in ECR, that registry in ECR, is where all of these images get pushed to, and the tag is the SHA of that, is the SHA of the file. So the CDK will grab a SHA and it's going to tag the image with that file. So anytime the file changes, that hash is going to change, and that's how the CDK knows to deploy a new version of that container image. Now, with this process, when you use what we call the default stack synthesizer, when you do it this way, that means all of your CDK deployments for that region are going to live in that ECR repository. Now, I understand that some folks don't want that. Some folks want a little bit more control. They want to have separate ECR, repositories for each individual app. There is a way you can do this using the app staging synthesizer, which again, this gets really deep into the CDK, so I don't want to confuse too much. But when you use the app staging synthesizer, What that'll do is that'll actually create your images, your ECR. It'll create a new staging bucket, which is where all those assets live for the CDK, like CDK specific assets that it needs, like IAM roles and so on for deployments. But also it'll create an ECR repository for your specific application. And then you can name it. You can name that image what you want. So if you stick with the default stack synthesizer, you just rely on CDK to fully manage this. You don't think about it. But if you want the ability to, maybe you want to provide that image to, a developer, the other teams want to use that image to test locally, you can use the app staging synthesizer. And furthermore, there's also an ECR. Oh, the name is escaping me right now. But there's a repository. There's a construct or a library out there that can actually take that asset image and then copy it to another asset image and tag it and name it as you see fit as well. So that's definitely something I can do another demo on down the road to show you what that looks like. But anyway, in this case, I'm just relying on the default stack synthesizer, which is going to use that shared repository. And actually, I'll log in there and I'll show you what that looks like in a moment. Okay, so let's go back now. And at this point, we have built our asset, or we have our asset definition ready to go. The only other thing I'm going to add here is my particular machine is I have an M2 processor, so I'm using ARM. I have an ARM processor, but let's just say I want to build this using, for some reason, most of the teams here, we don't use ARM. Everyone uses x86 based processors. That's okay. I can instruct the CDK when it builds to use the x86 processor. So I can make sure that this image can work on both whichever architecture I need. So usually what it'll do is it'll default to whatever it is on your file system. So in this case, I want to use x86, but frankly, you should probably use ARM because Graviton processors are cheaper and more performant. So anyway, okay. So we have our container image build process done and ready to go. Now what I want to do is I want to deploy this image to an ECS cluster using an application load balancer. I want to connect my running task, my ECS service, to that load balancer, which means I need a target group. I need to make sure that they can connect to one another. I need a listener, all these things, right? It's a lot of things I have to think about to get this built. This is where these abstractions in the CDK are super powerful and super helpful. So in this case, I'm going to use a very opinionated construct here. So I'm going to, let's do new ECS patterns dot application load balance Fargate service. And I know that's a mouthful, okay? But what this is going to do is create essentially, I don't know, it's something like 500 lines of CloudFormation code. And it's going to build the load balancer, all of the resources I need to run my application. And I can pass in the inputs to configure it as I need. So again, what we're going to do here is we're going to pass in, so oops, let's do this. Okay, so we're going to start by looking at my options available here. So I'm going to pass in a VPC, which is my VPC that I created above. So I'm telling the ECS construct here to, when it deploys my service, my Fargate service, I want it to run in this VPC that I defined up here, okay? Again, I could build a new VPC. This construct could even build a VPC for you if you want. Now, what I want to do, oops. So we have our VPC, and now here's where I can pass in my inputs. So you see I have all these configuration options available to me. In this case, what I'm going to do is I'm going to stick with a lot of the defaults, but what I do want is the task image options, and I want to pass in the container image. So in this case, I'm going to say container image from Docker asset, this asset that I created above. So I'm telling the construct here, I'm telling the CDK that when you deploy this ECS service behind this load balancer, I want you to use this asset image, this image that you built and pushed to ECR. This is the one I want you to use. Now, there's a couple more things I need to make sure. One is the container port. So I run it on 8080, and that's really all I need in this case. Of course, you can add more as needed. For example, if you want to, you have a file system you want to attach, like an EFS file system. There's so much more you can do. I'm just going very simple here in this case. I'll set a memory limit. I'll stick with 512 megabits, and I'm going to set a desired count for now. Depending on time, I may do something cool, but regardless, remind me if I forget. I'm going to show you how to enable auto scaling, which is really, this is again, the power of the CDK is it's one call to enable auto scaling. Okay, so what do we got here? I'm going to let it create a cluster. I don't need it to create a cluster. I have my VPC set, I have my desired count set, and I have my memory. Okay, that's it. So what I've done is I've told the CDK, here's the VPC I want you to deploy to, here's the image I want you to build. And using this higher level opinionated construct, I want you to build a load balancer, create an ECS service using that image, and deploy it for me. Because CDK, you're awesome. Thank you. I appreciate you. And I love you. Okay. See, I love the CDK. Big fan. Okay. So now we're going to run a CDK diff, because we never just deploy all willy-nilly. Come on. We gotta be careful here. We gotta know what we're doing. So you can see here, it's telling me all the things that the CDK is going to deploy on my behalf. And I'm going to, it's creating a load balancer. It tells me about the security groups, IAM policies that it's creating, and roles. So if you've ever used Terraform, this is very similar to like a Terraform plan command. And then it's telling me all the resources it's creating. So notice I didn't define an ECS service. I didn't define a cluster. I didn't touch security groups. This is another big one. Networking and IAM are arguably two of the hardest things to do in AWS. I said arguably, maybe they're not, but it can be, they're very tedious, right? This is creating the roles for me. It's attaching the role. Notice here, I didn't define logging. I didn't have to define where I wanted to log to. The CDK is going to create a log group, and it's going to make sure that my task can log to that log group. Okay, enough talking, Adam. You talk too much. So we're going to run a CDK deploy. The one thing I didn't, let me just make sure I've got, yep, I got AMD 64 there. Perfect. Okay, and we're going to run a CDK deploy. Now, this is going to take a couple of minutes. So I do have one up and running, but I want to take a quick pause while it deploys, just to see if anyone has any questions or anything I can touch on. So feel free in the chat if there's something you want to know more about or you want me to touch on. I'm glad to do it. But if not, I will talk about constructs in the meantime. So you can see my CDK code is deploying. Let's take a quick look here at constructs. Okay, so with the CDK, let's actually do this. I'm going to do you one even better. Ooh, I'm going to do good question. I love that question. Okay. Oops. Okay, so let's do this. So it's deploying right now. So I'm going to let this deploy, and I'm going to move this over here. That's not the one I want to move. Crazy guy. Okay, we're going to go here. Okay, so I want to talk to the question of Pulumi versus CDK versus Terraform. So the Pulumi and the AWS CDK, both open source projects, both allow you to imperatively define your infrastructure as code. So you can use a general programming language to define your infrastructure as code. I would say that really the main difference between the CDK and Pulumi, both great tools, Pulumi's awesome, is the CDK is very AWS focused. By the way, there is a tool called CDKTF. So there's a way that you can actually programmatically define your Terraform resources using the CDK framework. So that's CDK-TF, CDK for Terraform. But Pulumi AWS has a lot of opinionated libraries and constructs that simplify your life when deploying to AWS. When you start to go cross cloud, you want to deploy to other clouds, other resources. Pulumi is great for that. So I encourage you to check out both. They're both very good. Both have pros and cons. Personally, I've just been using the CDK for a long time. I'm just such a huge fan of it. And for me, I mentioned this earlier, anytime I can simplify the life of a developer, simplify the life of the end user that's building code, I want to do that. So the CDK definitely helps with a lot of that. Pulumi does as well. So check out Pulumi, check out both. Terraform, and also CDK manages state using CloudFormation. Terraform, however, so Terraform, you use the HashiCorp language, which is HCL. You can also define using JSON, but I'm going to be honest, I don't know. I don't think I've ever talked to someone that defines their Terraform code using JSON. But Terraform's, a product that you can use to define your resources in AWS or any other cloud or any other provider. So Terraform is really popular because it has integrations with a ton of open source projects, also SaaS providers, and so on. One thing I want to mention about, and with Terraform, you're responsible for managing the state of your infrastructure. So if you're using, I don't want to say open source Terraform anymore, it's Terraform, their new licensing model. There's also OpenTofu, which is a fork of Terraform. But you can manage your state in S3. You can manage your state in a few different ways. But you have to think about how you manage that state and where you put that state file. Whereas with CloudFormation, you don't have to do that. Okay, my deployment is done. So you can see I have these two outputs here. I want to put this in actually here. Let's go here, Madhu, if you don't mind. I know I can do it. What am I saying? I'm going to go to the comments here, and I'm going to put the link in here. So this is what for some reason I can't post from here. So I'm going to put this in the private chat. Madhu, thank you, Madhu, if you can post that. Okay, so this is the URL. So remember, the CDK created a load balancer for me. It created the ECS service. It connected the ECS service to the load balancer and did all of that hard work for me. Because if I were to do that, and actually, you know what I'm going to do really quick? Let's do this, because this is fun. Let's look at so what the CDK puts its resources in the CDK out directory. And then I have my template, which is a CloudFormation template. And then I'm going to do a little word count magic on it to see how many lines it created. So it's 439 lines of CloudFormation code that I was able to create in less than 30 lines of code. So 30 lines of code, done. Okay, this question, how to connect to S3. Okay, let's do that. First of all, really quick, let's do this. Let's go to here. This is my application. I'm going to zoom in. Okay, so this is that URL. If you want to have fun with it and you don't want to run a curl command on your own, go to the docs endpoint. Okay, go to summary. And again, I just deployed this right now. I didn't do any cheat codes or anything. This is just what we deployed now. Hit try it out. Term, enter your string. Let's go with Amazon Web Services. Doesn't always work perfect, but let's execute it. And my service was able to talk to Wikipedia and tell me I couldn't find it. Okay, not sure how you couldn't find it, but let's try Amazon instead. And then we're going to execute it again. Boom. So look here. So that worked. So I was able to deploy my application. It's running on an ECS cluster using AWS Fargate, serverless compute, load balancer, target group, IAM role to connect and to the logs, to pull the image. All of that, what we call boilerplate, was all taken care of for me. I didn't have to do anything. So let's go back now to, so anyways, if you want to play around with that, have fun, feel free to break it and no, don't go too nuts on it. But okay, two things I'm going to do and then I'm going to wrap up. The first one was, how do I connect to S3? Okay, that's a great question. So normally what you'd have to do is create an S3 bucket. So let's do this. Import all as S3 from the S3 library in the CDK. And let's create a demo bucket. And then we're going to do new S3.bucket. And then let's create this bucket. Now, I have all these options available to me. I'm not going to do anything with them. I'm just going to leave them as is. Maybe I'll name it. Let's name it because, that's going to help us. Container UG demo bucket / Adam is awesome. And you know what? I'm changing that. I am changing that to Dude is awesome. Okay. So I've created a bucket. Now, how do I connect it to the S3 bucket? This is the big one. Normally, you're going to create an IAM policy. You're going to attach that policy to the role, and you're going to have to do all that on your own. In this case, what I'm going to do is we're going to save this const, and we'll name this ECS deploy. Okay. And what I'm going to do is go here. It's tough when I'm super zoomed in, so forgive me. I'm trying my best here to see what I got. I think this is it. Yep. I'm going to actually zoom out one just so I don't lose my mind entirely. Okay, and we're going to say ECS deploy. And then what we want to access is our service. Okay, and I'm going to say grant. I'm sorry, I lied. Adam's a liar. We want our task definition. And then we want our task role dot grant. No. Boy, y'all, Adam's brain right now is fried. What we're going to do is S3 bucket, demo bucket. So I'm going to call this bucket, and I'm good. Now remember I told you we have these helper methods in the CDK that simplified a lot of the connecting of resources. So I'm going to say grant read, and I'm going to grant read. Let's see, actually, is that available? Oh, grant put. No, grant read. And we're going to pass in the ECS deploy dot task definition on task. Okay. So what I did here was I said create an S3 bucket, and then my ECS task needs to access this S3 bucket, but it only needs to read objects from it. I don't want it to put, I don't want it to do anything else. So with that simple one line of code, I run a CDK diff, and what we're going to see here is a new policy is created. That policy gets attached to our ECS service role, and that's it. That's all I had to do. So you see, I got this policy here in my role, and that's it. So that's how easy it is when you're working with the CDK to connect resources, leverage these abstractions, and do all that good stuff. The last thing I'm going to add before I go is auto scaling. So, if you want to use, and let's have fun here, add auto scaling based on request count. We're going to see if the AI can really work here for the ECS deploy service. All right. Let's see. Let's see if the AI is smarter than me. It is. Look at that. So all I had to do, oh God, I love these AI coding companions. They're so helpful. So what you can see here is I'm able to add auto scaling. Although, yeah, so no, I added the task count. So there's two things you got to do. So I can say the minimum capacity is 1, max capacity is 10. Okay. Now, what I want to do, let's see if it does this for me. Yes, it did. Oh, I love you, Code Companion. So I was able to, it did CPU utilization, so it kind of lied. Okay, but so now I have these options available to me. I can scale on request count, and I'm going to do this. I'm going to say request count 1. Okay, and I'm saying I want you to do for the target group for my ECS service. This is how I want you to auto scale. So I was able to add auto scaling to my task, and it handled it just in a few lines of code. What it's going to do is create that metric. It's going to use that metric in CloudWatch, create the alarm, create the auto scaling policy, and do all that behind the scenes. And all I had to do was just simply instruct it on what to do. I'm not going to deploy that today because I've been talking too long. So I'm going to wrap it there. Again, first of all, thank you everybody for listening to me ramble. Reach out to me if you're going to reInvent. Feel free to reach out. But also, if there's any other last minute questions I missed, let's make sure I touch on those too.
Cool, thanks, Adam. That was great. You look everything easy. I don't. That was great stuff.
Thank you.
I'm just looking at the questions as well, but that was great demo. Well done, Adam. I mean, I learned myself a lot from your demo and Darko's demo. So I'm definitely POC for me on the ECS Anywhere with Nathan's blog, and CDK a little bit. I will do some POC on this one as well. But what's your? I mean, there are no questions here, but what's your take on? I mean, before I jump into the question, are you okay, Adam? You're done. You want to wrap up with your...
I'm here all day.
I know, good man, good stuff. But what's your take on people who are like starting their journey into infrastructure as a code? I mean, I know who have a development background, they choose probably a CDK or Plurmy or because they have some knowledge on Python or some part of coding. So what's your take on that? Like two sectors, right? So one who are new to infrastructure as a code with no development background, and the other one is with development background. So what's your suggestion as a technologist? What do you recommend?
I love that question. Yeah, I love that question. Thank you. And I'll tell you this. I think so. To start, sometimes when I talk about CDK, I get all excited, crazy. But one thing I want to make clear is you have to build using a tool that's going to make you the most successful. So for me, I love imperative languages. I'm imperatively defining my infrastructure as code. I love programming languages. I like leveraging that. But I know people, and I have friends and colleagues that don't, and that's okay. Like, you don't have to. So I think the first and foremost question you have to ask yourself is, how do I want to work with infrastructure as code? So if you are more comfortable with a declarative language like YAML, stick with YAML, or something like Terraform HCL. Like, HCL is a very easy to learn and understand framework. But so that's the first question you have to know. And if it's not just for you and you're building for your team, I always say build and design for what's going to make your team most successful. If everyone on your team is a developer and they prefer to read code, then you're going to probably want to use something that it's going to be easier for them to jump into and understand and read. So that's number one. As far as like getting started, I would recommend, first of all, start small. My biggest problem, and I'm sure everyone experiences this too, is you want to boil the ocean right away. You have 10 million things you want to do. I want to do all these crazy things. Don't. Start very small. And you can even start as small as like build an S3 bucket, build a DynamoDB table. Do just one thing, understand the concepts, and then build from there. There are workshops out there. AWS builds a ton of workshops. I got to find that link, but we have a workshop studio. But if you're interested in the CDK, there's cdkworkshop.com. If you're interested in ECS, there's ecsworkshop.com. If you're interested in Kubernetes, EKS, there's eksworkshop.com. So there's a lot of workshops out there. And by the way, maybe Oh, perfect. Thank you. Yes, man. Yes. Look, there's a ton of options, but find a workshop and use that as your starting point, because oftentimes it's hard to also find a use case to build for too. So I think that's kind of the approach and like the workflow that I always work through to figure out how I'm going to build something and how I'm going to move forward. I'm going to tell you, there's always going to be um, there's going to be challenges. But nothing is super simple. I always say, yeah, I'm guilty of this. I say, oh, it's so easy. This is so easy. Know that it's going to be a journey. You're going to have some challenges. You're going to run into them, but that's okay. There's communities out there to help, and especially in the AWS world, there's solutions architects. There's developer advocates out there. Go to conferences. Go to meetups. Ask the meetup organizers. They say, hey, I'm really interested in this particular thing. And, Madhu came to me and said, hey, do you want to talk about this? Yes, please. I'd love to talk about it. So there's resources out there. Also for CDK, there's the CDK Slack channel, cdk.dev. Check that out. That's a great resource also as you start to build on CDK where you can get help. But kind of a long drawn out answer, but I hope that makes sense. Answers the question.
Absolutely, absolutely. Sure, sure. Thanks. Great insights, Adam. And yeah, what a wonderful session. Yeah. So thanks for coming and accepting my invite. It's a great knowledge sharing today with Docker and yourself. And probably we will. I will see the feedback as well. We can always arrange a follow up into something deep dive or anything other as a follow up you would like to bring to the community. Please feel free. So we can arrange that. We can organize that.
Awesome. Thank you so much. I really appreciate being here. Y'all are awesome. Thank you. Great questions too. I always love when people ask questions. It makes it more fun. I feel like I'm not talking to a wall, So
Absolutely. It's a great audience, great comments. I'm just showing by a few before I wrap up. But yeah, thank you guys. Thank you. And thanks for joining today. People like you make me, go to the experts like Adam and Darko and Nathan to bring up and share, bring more knowledge to the community. So please, please let me know if you need anything on follow up on this topic or any other topic which we discussed today. I'm happy to arrange another follow up session with them. Thank you, guys. In that case, there are no other questions, Adam. Thank you very much. Thanks to our audience, and I will say call it a day. Thank you, guys. Bye. Have a good rest of the day. Bye now.
Thank you.